Okay, my talk is entitled How to Tame a Penguin. Why a penguin? Well, this penguin here, his name is Tux, and is universally considered to be the mascot for Linux, the Linux operating system. And this is me. I'm Brendan Richards. I'm a solution architect at SSW. I spend a lot of my time on client sites, writing websites, and I've been a Linux user for a long time. And I've been a .NET developer since 2004, so when the announcement came that .NET was going to run on Linux, I got very excited, and it's bringing kind of two areas I've been interested in for a long time. They're coming together, and I'm hoping to kind of be able to use both sets of experience to deliver this talk. So what am I going to talk about? Well, mainly the overall theme is you're a .NET developer. You've maybe heard of Linux, you've maybe tried it a bit, but you don't really know where to start or how to go about starting to use it. So the real theme here is to give you the pieces of information you need to know to understand what it is you're looking at. I don't expect everyone to remember everything I say, but if you, so next time you're sat in front of Linux and you see an error message, you think, oh, I remember there's a way of getting around this, there's a thing you can do, and I can't remember what it is, but then you've got a kickstart of what to Google, then it's going to help you in the future. So my first section is called May You Live in Interesting Times. This is a general kind of history, where we are and how we got here. My second section is called Packages All the Way Down. So to understand how to install software under Linux, you need to understand the package manager system. Next section is I logged into a Linux server and all I got was this lousy $ prompt. At some point, now you can use Linux using a graphical user interface, but most people at some point need to jump into the command line to do something. So this goes straight in and teaches you some command line basics to get you going, hopefully to make you slightly productive under that environment. Then when all that background's in place, we move on to installing .NET Core on a Linux box, and then we'll create and deploy an ASP.NET web application. So the first section, May You Live in Interesting Times. Well, I think it's fair to say that the relationship between Microsoft and Linux hasn't always been a particularly good one. If you don't know this guy here is Steve Ballmer. He was the then CEO of Microsoft, and this is a genuine screenshot from a register page. So at some point in the last 10 years, we've gone from this to this. Quite a big change. So how did that change happen? Let's take a look at the landscape. So traditionally, when you're talking about computers in the modern world, there's generally one of two types. Now there are other systems out there. There's some educational departments have got their own kind of experimental operating systems, but most systems you see out there in the world have one of two types of kernel. One is the NT kernel. That's running things like, we first saw it in Windows NT 3.1. It was numbered 3.1 even though it was the first one that came out. And that's a kind of pattern that stayed around in Microsoft for a while. All the way through to Windows 10, Windows Server, Windows Phone, and Xbox One. On the other side, you've got what I've called a UNIX kernel. That's pretty much everything that's evolved some way from Unix from the 1970s. Now, Unix is very old, and when it was created, computers were massive, big, kind of wardrobe-sized things that everyone had to. You interacted with that computer through a terminal, and it was built to support multiple users across one computer. Was used by 50 people, say. Since then, that general pattern has been re-implemented a number of times in both the Linux and the BSD systems. But those two systems, Linux and BXD, are the base for Mac OS X, or just Mac OS these days. iOS running on Android, on iPhones, sorry. The core of Android phones, and Chrome OS. So what's interesting with this divided list is when you look at phones. Who here right now is using a Windows phone? Any hands up? We've got one. Who here has got an Android phone? Quite a few. Who here has got an iPhone? So Androids are winning, but still quite a few iPhones. One more question. Who here right now has a Windows-based laptop with them? So most people. So pretty much you're looking at, I would say, a 50-50 split. So right now in this room, there are as many Unix-based operating systems, Unix-based computing devices in the room as they are NT-based devices. And this is a .NET user group. We're a Microsoft crowd. So that's changed a lot in the past 10 years. So that's the traditionally divided landscape. And I think that growth towards phone and the fact that Windows Phone didn't take over the world has led to a big push towards Linux and kind of non-NC based systems. So Microsoft have stepped up and they've got quite a few systems now. They've done a lot of work, they've made a lot of technologies that cross that divide. First and foremost with Microsoft Azure. So when they released the cloud, they realized there's a huge amount of web systems out there that don't run. They either don't run at all on Windows-based systems or they run very poorly on Windows-based systems. So thousands and thousands of WordPress sites and all the rest of the web basically. And so when you're launching a hosting provider, you want to get people who's hosting their stuff on you and giving them money. So they said, we don't care what you run, as long as you run it with Azure. So that drove a huge push within Microsoft to actually start accepting and understanding this other technology. Then we had Xamarin. Well, Xamarin comes straight out of their phone system when they realized that there's this thing called Mono lying out there that's been a completely open source project, completely in the open source world, that's a re-implementation of the .NET APIs. When they realized this and brought it out and took it in place, it meant that you can now use your Windows skill set to develop software for iPhone and Android, and it's still the #1 way. If you want to write code in .NET code or .NET style code and have it compile and run on a phone, Xamarin's now your way forward. Personally, I'm thinking with this ASP.NET Core stuff coming along, I'm not sure whether Mono is going to be around for much longer. Right now, there's been no announcements. This is totally a personal opinion. I know nothing, but I can't see if you've got this open source ASP.NET Core in 5 years' time, why you'd need to have Mono as well.
And Visual Studio is now on Mac as well.
That's right. The announcement there was Visual Studio on a Mac, and so that's a big change. So all these systems are coming together, and it's no longer quite important what operating system you're running. It's more about what practices and patterns you're using. So the next thing on here is ASP.NET Core. A huge amount of work. It would have been so easy just to carry on and make a .NET, .NET 5, but the realization is you cannot live in a divided world anymore. So the amount of work and the amount of pain it's taken to get here is incredible, but now we've got an ASP.NET Core program that runs on Windows, Mac, and on Linux. Visual Studio Code. We love Visual Studio Code. We actually use it quite a lot for all our JavaScript style work in TypeScript and Angular. And it's really small, it's really fast, and it runs really well. And finally, I thought I'd never see this day, even SQL Server has been ported to run on Linux, and it runs well. It works. It's fantastic. Okay, so there's some good reasons for using Linux there. How do you get some? Well, the first place you can look is, of course, Azure. If you're .NET developers, there's a chance you've got an MSDN subscription of some kind. With that MSDN subscription, you've got a bit of personal free hosting space. So get yourself a Linux VM and host it that way. Or you can host in any other provider. There's free tiers on Amazon. There's cheap virtual private servers around from around $10 a month. Or you can start looking at virtualization. That's something I'm going to show you today, because for a presentation, to get a really nice looking terminal up, I'm using a Ubuntu instance on VirtualBox. But there's other virtual providers. There's VMware. There's also Hyper-V, and that's built into Windows. Docker is very exciting technology. It's a talk in its own right, so I'm not going to do much with it apart from mention it. But what Docker is containers. Instead of running full big virtual machines, it's making tiny containerized virtual machines. So it's much easier to deploy across lots of, say you've got a web server, it's shrinking down the server that is that web server until it's just the web stuff and the stuff it needs, and then putting it into these containerized systems. Now what containers do is they've got some really clever stuff that actually shares files between all the virtual machines on that box. So straight away you're shrinking down the amount of storage capacity you need to launch a big cloud of servers. Another way to get a Linux box is to pick up an old machine from somewhere. Chances are you're ready to get it to run. I've got a home theater PC kicking around my lounge room. It's used to be my desktop that I bought in 2006. So I've swapped out a few bits, put a new hard drive in, put Ubuntu on it, and now my kids just click the Chrome icon and type Netflix to browse Netflix and watch their cartoons. They don't know it's Linux, they just know I click here and type Netflix. Raspberry Pis are pretty cool. Tiny systems, cheap systems that will run a full Linux stack, and the amount of stuff a Raspberry Pi can do is growing each and every version. We're now on Raspberry Pi 3, and they're a pretty decent system, just in this tiny box. And finally, another very, very cool new technology is the Ubuntu stack on top of Windows 10. The way this works is at a very low level kind of area. It will run a kind of cut down or a specially made Linux kernel. It's not the first time there's been a kind of run a Unix style stack on top of Windows. There was a system called Cygwin that's been around for quite some time. But the problem with Cygwin is it installed itself at a kind of driver level as a system and then create a virtual system for the Unix. But all the programs you wanted to run on top of Cygwin had to be specifically compiled for Cygwin. So you were kind of limited to one distribution and one kind of weird package manager. What they've done with the subsystems for Ubuntu is they've made that core that they've just hacked to run on top of the Windows stack 100% binary compatible with Ubuntu. So you install the same packages from the same package sources. Okay, so that's a little bit of history. I've said the word packages already. Let's look at the section called packages all the way down. So what I'm going to talk about here is a little bit more around the Linux architecture and how you have to understand packages to understand how to get software in and out of the system. Here's a quote I quite like by Jeff Atwood, the coding horror guy. And it's not that Unix is particularly good, it's just that everything else ended up being even worse. And what I think is meant by this is no one tries to make terrible things, but every now and then, best of intentions, you'll make something that in some way sucks. I liken this quote to the Leo Tolstoy quote, where each unhappy family is unhappy in its own way. So let's take a look a bit about Unix architecture and the philosophy of Unix. So the Unix philosophy is write programs to do one thing and do it well. Write programs to work together. And write programs to handle text streams because that is a universal interface. So the core concept here is don't make big overcomplicated programs, don't reinvent the wheel, try to avoid the not invented here syndrome, make a simple thing, and then if you want to add features to that simple thing, make another simple thing that wraps it, and so on until you build up out of these simple components. So how does the Unix philosophy hang together in the system architecture? You note I've put Unix architecture here and not Linux architecture, and that's deliberate because this is the system, this is the kind of layout that applies to all Unix systems, including OS X, including Android phones. So what you've got here in the middle is something called a kernel. So the kernel is the system, is the sort of lowest level system that sits between you and the hardware. You interact it with system calls, and that's the system that manages running processes, managing those processes. Then on top of that, there's generally something called the shell. So the shell is basically sits around the system and gives you an environment to run programs in. Then around that, you've got your applications. Sometimes they go via the shell, sometimes they make direct system calls themselves, and sometimes, many times, they use various libraries to get their work done. So when we talk about Linux, what we're actually talking about is the kernel. That's the bit in the middle. So the Linux project is in fact just a Unix kernel. It's a system that sits between you and the hardware and gives you this interface to run programs. Now the Linux kernel was released in 1991 by Linus Torvalds. On top of the Linux kernel, there's something called the GNU project. GNU stands for GNU's Not Unix. It's an example of a recursive acronym where the first letter of the acronym stands for the acronym itself. It's something that, for some reason, open source people find hilarious. But this system was actually first built way before Linux. So when Linux came along, there was already this library of open source software written for a Unix environment that they could just drop on top and turn it into a complete system. So the story behind the GNU project is there was this guy called Richard Stallman who worked in a university. I think it was Berkeley, but I might be wrong there. But they shipped a printer to him. He had a brand new printer come in, and it couldn't quite do the things the previous printer could. So he phoned them up and said, there's a few problems with your printer driver. Send me some code and I'll tweak it and we'll work together and fix it up. And for the first time, this is way back in the 70s, they turned around and said, well, you can't have our code. That's our proprietary technology. You can't have our source code. And that had never happened before because writing programs happened at universities. People just shared everything they had. And Richard Stallman was so infuriated, he went on to form the Free Software Foundation. And that sort of started off with taking all the utilities they used on top of a Unix system from day to day, rewrote them as open source versions. So all the real core utilities, a lot of the commands you'll see written today were originally written by Richard Stallman as copies from what was provided by the Unix of the time. Then on top of that basic system, you've got the unwashed hordes. Thousands of various projects for in all kind of types of people and all types of places, making all sorts of software. And all this lives out on various CVS repositories, Subversion repositories, sitting there on GitHub. And it's all there as code. And so how do you make sense of all this mess? That is where distributions come in. So these might be more familiar libraries. So what distributions do is take all this source code and turn it into a complete coherent system. So what they do is take source code that's been released by whatever open source project, and they turn them into binary packages. They put those packages on package repositories. Now, as you can imagine, with this whole concept of not inventing the wheel, do one thing, do it well, you wouldn't rewrite lots of bits. What you do is you take dependencies on the other part. So there's a huge tree structure of dependencies of programs that rely on other programs. So what the package repositories do is keep track of those dependencies. So when you say to the system, I want to install X, it'll say, for X to run, you need Y, Z. Let's download those two, put them on your system, it'll run. So with that, they introduce system-wide consistency by making sure the version of Y that's a dependency for X is the right version that it needs. They then make installer programs and DVDs. So you can take your DVD ISO, put it in your system and install it. There's even there's different types of distributions. There's even simple boot off the CD distributions. They just boot off the CD, run there in place, and you use them for sort of repair CDs, that kind of thing. And they then distribute that software and run support and forums. So when I say packages all the way down, what I mean is everything in the system, including the kernel, is a package. Many errors that you'll see using the system can be fixed just by getting the right version of the right package. It also means you can update all the software with a single command. So say you run Windows Update, what you're updating is Windows and maybe a few other Microsoft pieces of software. When you run an update on a Linux machine, you're updating everything that was installed via that package manager system, which is most of the system. So with that, there's a few places to get software from. Of course, there's what's called the official repositories. These are the repositories provided by your own distribution. And it's a pretty complete system in its own right. Most of the stuff you need is on there. Then you get what's called unofficial repositories. Now, by unofficial repositories, it's a perspective thing. Unofficial repositories from the perspective of the distribution provider. For example, Microsoft have a bunch of repositories so you can add Microsoft software to Ubuntu. They're considered to be an unofficial repository from the point of view of Ubuntu, even though they're the official repository for Microsoft. This is where Microsoft puts their stuff. Some languages, such as Node or C#, they have their own package managers built in. In C#, you use NuGet. With Node, you use npm. So sometimes you can install packages using those to download directly from Node or download directly from NuGet.org. The rule of thumb I use here is if I've got a piece of software that I'm installing just to use that software, just to use as a system, like some Java program that I'm using to talk to my database, I'll probably just download it through the official repository and not worry about it. If that's the programming language I'm using to use my work, so I'm doing some work with Node, I will get Node from the Node repository. It's unofficial for the distribution, but Node's official repository, and get the latest version, and then use npm to install all my JavaScript packages, because then it's the thing I'm working with, I need it to be up to date. So I have a base system that's kind of default, and then the system that I need to be the latest, go and get that from the unofficial source. Some vendors still give you binary installers. Say Oracle Database is a key example. I know VirtualBox has some binary stuff they install when they go into your host system to make it work well in that hosting environment and making drag and drop work between you and the host program. And finally, you've got a nuclear option at the end. If there's a piece of open source software and there's no package available for it, you can always download that source code and use the compiler to compile it yourself and install it that way. I've not had to do that for about 10 years, but it used to be something you had to do quite more often. So with all these packages, you get a lot of modularity. Linux distributions can be big or small. They can run in many places. I've even got a Linux box running on a little Asus wireless router. It's got a Broadcom system on a chip, and you can just flush the BIOS and replace the kind of pretty rubbish web interface it has on it with a complete Linux system. So you've got all the kind of standard Linux tools for routing your hardware, so routing your network traffic, all that kind of thing. And with that modularity, pretty much any component in there can be swapped out for an alternative. There is a countless number of different graphical user interfaces, for example. There's KDE, there's Genome, there's Unity, which is the one built into Ubuntu, and a whole bunch of other smaller cut-down ones built for lower spec hardware. But with that modularity, there is a drawback. For every possible choice, you will find an argument flame war quite heated online. I've got this particular cartoon in here, not because I find it particularly funny, but because just how old it is. Vi and Emacs were both text editors in the 1970s, and there was arguments about which one was best, stretching way back. A bit silly because Vi is clearly best. I logged into a Linux server, and all I got was this lousy $prompt. So you log into a Linux system, and you've given this black screen with a $prompt. Where is everything? I might have seen that before. I've been messing around with Windows, and I've opened command, and when I open up command, generally somewhere in the C drive. Well, in Linux, there's no C drive, so you're lost. There is also no registry. Everything is configured with text files sitting somewhere on the disk. But where is that stuff? Well, there is no C drive. What there is instead, there's a single directory structure starting with a / and everything between is /. And when I say there's a single directory structure starting with a /, absolutely everything in the system is under that /. So you don't have your C drive and everything under from C down, that's your one hard drive, an A drive, and that's where your floppy drive is. And then if you want to look at your network drivers, you're going to go to the device manager. You want to look at your printers, you go somewhere else. Everything is under /. So all files that have been mounted on any hard drive across the system. All devices appear as raw block devices under /. So if you knew enough about the hardware and knew what bits to send, you can communicate directly with your hardware. You've also got a virtual file system under proc, and that's a kind of system that lets you see stuff about running processes and CPU information. And the last thing I'm going to show you here, there's symlinks. Symlinks are basically little nodes on that file structure that point to other places on the file structure, like an alias. Think of it a bit like a shortcut in Windows. If you create a shortcut in the Windows GUI, you can click on it and it opens like a directory. But if you then go and open it up in the command prompt, it's just a file with .lnk on the end. A symlink is a bit like a shortcut, but it's much more low level. You look at it through a command line, it still looks like the file it's supposed to be. It's a really low level thing. The NT does have some stuff like that. It's got something called a junction point that you can create and works like a low level redirect. But symlinks are quite crucial to understanding some of the bits and how we hang things together inside a Linux system. So let's have a quick look through a few of the locations where stuff has been put underneath that / folder. Anything with bin in it stands for binary. That's actually executable programs. /dev is where you'll find devices. You pretty much don't need to poke around in there unless you need to kind of remount a hard drive and you just need to know where your drive is. etc is a folder that contains lots of text configuration files. That's your general system configuration. Home is your user home folders. That's where any kind of user, if you've got a program that has some configuration that's stored per user, it'll put a little hidden folder in your home folder, and that's where you put stuff. Now you'll see this happening more on the Windows side as well. If you go to app-data/roaming, you'll find more and more configuration files are sitting underneath that stuff. I mean, I know NuGet under Windows now, it puts a .NuGet folder in your home folder or under app-data/roaming to put its configuration, to be consistent, because they want this stuff to work across both platforms. Then /proc is a virtual file system for system information. It kind of puts nodes on that tree structure that lets you query stuff about your hardware, query stuff about running processes. And finally, /var is for runtime files. If you've got a program that makes logs, it'll write logs to /var. If you've got, say, a database, the data files for that database will typically sit under /var. So let's move forward from that introduction to take a look at the shell. So the shell was a program we used to interact with the machine via the command line. It's the command interpreter, the equivalent of CMD commands in Windows. And like pretty much everything, there's more than one shell available, but the default at the moment seems to be bash. So it also provides an environment under which programs execute. So what I mean by that environment is a typical command line program looks something like this. You've got standard in, which is a stream of input text. It gets fed to the app, and the app writes out the standard out, another stream of input text. If something goes wrong, it writes out the standard error. So let's take a look at running some commands. Now I've got quite a few things to get through, so I'm just going to run through a few things. I don't expect you to remember everything, but just give you a pointer of the kind of things you can do. Starting with putting my right password in. Okay, here it is. Here is the blinking dollar cursor. So let's start with a basic thing. Who am I logged in as? I'm logged in as Brendan. Where am I? PWD stands for print working directory. And I can see I'm in a folder called /home/Brendan/code. If you want to look at what's around me, I can type ls and get a listing of files. That's the equivalent of dir. Let's take a look at our first switches. I want a bit more information.
Can you zoom in?
Sorry?
Can you zoom in?
Zoom in? Yeah, I can make that bigger. Sorry, bear with me. That's under here somewhere. Got to edit this profile. Then go to custom font. Is that a bit better? Okay, let's look at our first switch. So generally, you have a command, and then after the command, there's arguments separated by spaces, pretty much like in DOS. And typically, you have a dash and then some switches. So that basically gives us a bit more information from that. So how do I know all about these command switches? One of the most useful commands you can know is man. It's short for manual. Type man and the name of a command, and you'll get a full list of all the command line switches you can use. And what you'll see here is quite often for any command line switch, there's a kind of short variant and a long variant. My rule of thumb is if I'm just typing it out once for myself, just in front of a screen while I'm working, I'll use, if I know it, I'll use a short variant. As soon as I'm writing a script that's going to be read by someone else or stick around for a while, I'll switch to the longer variant because that's more usable. Then you've got CD, we change directory. Big difference is you can't do CD ... like you can in DOS. You've got to do CD space ... Another special character you've got, echo is a command that sort of spits stuff straight back out to the screen. If I take a look at tilde, tilde is a kind of magic thing that's set back to my home folder. So I can quickly get to things under my home folder with tilde/code. You notice that jumps there. What this command line has is very good tab completion. If I start typing cd, type co, hit tab, it finds code. That does work in DOS, but the one here is slightly better. If I create a couple of files, let's go and make some files first. So in this case, what I've done is I've wrapped that command in quotes. So instead of it being 2 arguments, it's now 1 argument. And that spits out that value straight back from standard in to standard out. The next thing I'm going to show you is this redirect character. Same as in DOS, I can use that to redirect to a file. One thing that's worth pointing out, this .txt extension under Linux means nothing. There's no special interpretation of file names. File names can be anything you want them to be. Next thing I'm going to show you is cat. Cat is short for concatenate, and that's to print out a file. Next thing I'm going to show you is a variant of that. So a single writes to a file, a double appends to the end of a file. Now I've got 2 lines. I'm going to create a second one. To show you something else, if I type cat HE and hit tab once, it'll find out, it'll match as far as it can and knows, okay, for those switches, for that prefix, hello is as far as I can get and be unique. If I hit tab twice, it'll list all the files that start with HELL, and if I type then 2 and hit tab, it then knows hello 2. So it's quite fast to move around there. Final thing I'll show you, cat doesn't just print out files. If I go to the special proc folder, CPU info, it'll give me lots of information about the processor. That's the first section. Let's move on to the next now. If I try and do something I'm not allowed to do, it will tell me permission denied. Okay, so this, I think everyone probably knows this command. There's a command called sudo, which stands for super user do. So if I take that command and prefix it with sudo, it will ask me for my password and then work. Now, there's no way I can do this demonstration without showing you this, because I've tried and people just tweet it to me anyway. This is the classic xkcd on sudo. Let's zoom in. There we go, that's better. And so another thing I can do, if I go sudo who am I, it temporarily, so once you've typed in your password for sudo, it will stick for about 5 minutes or so, and that's configurable. So I don't have to keep typing my password, so I'm authenticated for a short amount of time. So in that case, I got privilege escalated. It ran that single command, who am I, said I'm root, okay, but if I go straight back again, the key thing is that privilege escalation is temporary and only lasts for as long as that one command. And it only runs 1 command at a time. Next thing I'm going to show you is the shell itself. So when we're looking at, what we're looking at here is 2 programs running. One's called a terminal, and what it does is it takes the key presses I type and sends them to a program, takes the output from that program and puts it back on this terminal here. The other one is the shell itself. The shell program is what reads what I've typed, interprets, runs stuff, and sends it back. I can do this a few times. I'm now running a shell inside a shell. I'm now running a shell inside a shell inside a shell. I'm running a different shell inside a shell inside a shell. And then I can exit to come back. So it's kind of nesting programs and inside programs, inside programs. Each one is taking its input, passing through to the next one, passing to the next one, and finally there's one that executes the command. It bubbles all the way back up again. Okay, the next thing I'm going to show you is it happens quite a bit, but you'd never sit down and type sh 3 times, but shells inside shells do happen quite a lot, and it's one of the key factors behind this next command, which is SSH. So SSH is secure shell. What this does is opens up an encrypted connection to a remote server, runs a child shell on the remote server on that machine. So if I type commands from that point, it tunnels through the network, runs the command on that shell on the remote system, comes back through the network and displays a text. Type the wrong password. Okay, so I'm now logged into a machine that's on the cloud. That's an Azure virtual machine. I've got it there, says running a copy of Ghost, which runs my blog using NPM. And now if I'm looking around, I can just do my work on a remote machine. So one thing that's useful to know if you are going to log into a remote machine is you do need some kind of text editor that works just inside the command line. Because now this machine I'm working on now has no user interface. It's just a server machine. So there's plenty of text editors out there. The one I recommend you have a look at first, even though I quite like Vi, is Pico. The reason I'd go that is actually quite friendly, looks quite simple. You can shift and control V, control P to paste, and the commands are listed there underneath. So if you get that installed, it's pretty useful to use. Next thing I'm going to show you is a program called apt. So apt is the name of the package manager program inside Ubuntu. Different distributions have different package managers. In Red Hat it's called RPM and Yum. In my favorite name for all the package managers is a distribution called Arch Linux. Their one's called Pacman. But on this particular system, on Ubuntu, there's actually two programs. It's a case of not reinventing the wheel. There's a much older program called dpkg, which is the Debian package manager. And what that can do is it can take a package and install it on your system and uninstall it and manage dependencies. What apt does on top is add some network capabilities. So when you install a package through Debian, the dpkg, and try to install it and there was a missing dependency, it would exit and say there's a missing dependency. Now if you use apt, it will say it's a wrapper on top that not only calls the dpkg to run the installer, it also picks up a missing dependency, goes to the remote repositories on the web, downloads those files, and installs them. So let's use apt to look at some stuff. If we go apt show, it gives us some information. Apt show, sorry, a program. We just saw sudo. Let's take a look at that. There's information all about the sudo program, the sudo package. Next thing I can show you is this pipe character, that pipe character there means take the standard output of the program that was just been running and feed it into standard input of the next program. So I can take these text streams and stream them through a number of programs. In this case, the program I'm going to show you is grep, which is basically run through this stream of text and take up the lines that match this text. And the text I'm going to put in is depends. So if I do that, I get a shortcut showing me the list of dependencies that sudo has. You don't really need to worry about these dependencies unless something breaks, but that's the name of the packages that sudo needs, and if I install sudo, it'll install those for me side by side. Finally, you can do a search for programs. That's apt. There's a list of all the packages that mention sudo. And finally, you can do some things the other way. Say I've got a file that's given me an error message, and the error message is giving me a file name. I want to know what package that file belongs to. This is probably one of the most useful things for debugging something. An error message come back, something's not right. Here's the name of a file. What package that file belongs to? To do that, you go to the low-level dpkg program, -s. And let's go for something really simple like bin. The ls program. And that will tell me that that belongs to a package called core utils. I go apt show core utils. There's information about that package, which is basically a set of the GNU core utilities, the real basic things like list and cat. And it's something that's generally expected to be there on a system for anything to work. Okay, so we've taken a look at some processes, How do we find out more about what's running, our running processes? The first thing to look at is top. This is the sort of same as right-click as your process manager. This sits there and updates once a second and tells you what's running. As you can see, there's two things popping up at the top. One called compiz, that's a part of the windowing engine, and the other is SQL Server. So it truly is a cross-platform world. I can sit here with SQL Server on my machine using resources when I'm not asking it to do anything, just like I can on Windows. Next thing I'm going to show you, and I'll try and get a couple of terminals open for this. Side by side. Okay, on the left-hand side, I'm just going to type cat and not a file name. It's now just sitting there waiting. So what I've done, I've told it to print out text, but I've not told it what to print out. So it's just sitting there waiting for text to come in on standard input. The reason I'm sitting that open is I want to take a look at how do I find out about a misbehaving process. Well, I can type PS, and I see the processes that are running underneath that context. We'll go PS A, I think. I see a lot more processes running. And I can see there's a process here called cat. That is that process. So what if I found out through top that that process is misbehaving? How do I get rid of it? Well, that's the kill command. If I type kill and then the number of the process that comes up here, 5260, it's terminated. So what that does is it sends a signal. It's the same as a Control-C break signal, and that's kind of a please shut yourself down message. So that program will accept that signal, close any open foot processes it's got, do any cleanup it has to do, and close itself down gracefully. But what if I try that, and it's in so much trouble, that process, that a straightforward kill won't actually kill it? Then I can do -9. Oh, no, I need to look at the process number first. Okay, I've looked at the new process number for that second process. It's 5278. So if I do kill -9 5278, it doesn't say terminated anymore. It says killed. So if no matter what that process is doing, that'll force it to die. The kernel will just take away all its life and just kill it immediately, and that is an immediate death. That is a pretty hard way of killing it, but that's immediate, and that always works. One more thing I'm going to show you is background processes. There's a GUI type text editor as well called gedit. You can also run Visual Studio Code from here, and I'll show you that later, but I'll just show you this. So this particular program runs. There it is running. I can type into the text. But you can see it's kind of running from that terminal. If I kill that terminal, kill that process with Control-C, it's dead. What I can do instead is put an ampersand after it. That now runs in the back-end process. You can see I've returned here. I can run more work. I can run more programs here. If you want to take control of that program that I've backgrounded, I can just type FG. I've now got control of gedit. If I Control-C from there, I've killed it. Okay, so that's quite a lot of commands I've shown you in a very short space of time. And I don't expect you to remember all of that, but hopefully you've got an idea of some of the things you can do when a few starting points to get processes up and killed again. One big tip is what you need is a cheat sheet. So this is a product by XKCD. It's a cheat sheet printed upside down, so you can glance down on it and look up some command line switches while you're working away. It's also available as a skirt, so everyone's covered. Okay, so now we've gone through, we've got a bit of background information on how to use a command line terminal. Let's actually go ahead and install .NET. I think you've realized by now that when you are dealing with Linux, you need to use a package manager. So you don't get to download an MSI and install that MSI file. People in the Unix world do not like binary installers. They'd much rather have a package manager. And there's a good reason for that, because if you've installed it through a package manager, when an update comes, it comes into your natural chain of your update process. You've got to, once every now and then you go to your machine, you say update all the software. Updates and security fixes for all your software will come through that channel. So you go on the website and you find the page for Ubuntu on the .NET code, and what you get on the .NET website, and what you get is this big pile of text to run to get it installed. So let's take a quick look at what that does. First line, sudo sh-c. That's sudo, you've seen that, run a super user. We're running a child shell in the super user. The reason we're running a child shell is because sudo can run one command and one command only. You want to run a bit more than one command, so you create a kind of child shell and put that command inside it. So we've done a privilege escalation. Inside that privilege escalation, we're doing an echo. Echo is send some stuff to an output stream. We're doing an echo, some text, redirect to a file handle. So we're taking all the stuff that's in the orange here and redirecting it to the file .netdev.list. You can see the location of that file. It's under etc, so it's a configuration file. It's in apt. It's the configuration file for the package manager, and it's in a folder called sources.list.d. So this is where we keep our package manager sources. So what effectively we're doing is we're adding a new package source into our apt configuration. It's the same as adding a new package source in NuGet. Once we've done that, all packages that you install on .NET are signed. Node needs to step up here and actually start signing their packages on NPM. But they're signed, so people can't inject bad programs in. They're signed packages from Ubuntu, and if you want to accept an unofficial repository source, you add a key and say, okay, this source from Microsoft, I trust it, I'm going to accept packages from the Microsoft server. So that installs the key into apt, and finally you run apt get update. So there's quite a lot of information the system has to know about these packages, what the dependencies are, it has to be able to index them quickly. So what apt get update does is it hits all those repository sources, downloads metadata about them, and indexes it. So when you sort of query the system and say, oh, what packages does this depend on, it will find it quickly. So apt get update is the first step to updating something. It updates your index. Then once you've updated your index, it's apt get install to install your program. And that's pretty much it. So let's go through now and deploy an ASP.NET Core web application. Okay, I've moved to my code folder, and I'm going to create a new folder called MVC. And inside that folder called MVC, I'm going to start using .NET. Let's start taking a look at the version, make sure it's installed. Probably double dash version. There we go, we have the .NET command line installed and running on Linux. So the first thing we can do is we can do .NET new. So what .NET new does is it has a series of templates we can use to start our projects from. If we want to take a list of those, I can do -L, and it lists the templates that are available. And you can also install additional templates. I'm going to start with an MVC template, just because it gives you a little bit more to look at when I get it running. So .NET new MVC, go. That's it, it's created a template. So let's take a look at what it has created. If I type code, dot to run Visual Studio Code. And here we are with a pretty basic MVC solution. And the key thing here is what you've got here from the code basis. You don't have a solution file, but you can add one. Everything else is pretty much exactly the same as what you'd get if you did a new project with a right click or a file new project in Visual Studio. So we've got, with .NET Core, your web applications look a lot more like console applications. It's console applications. Let me There's a console application that runs, bootstraps its web host builder. It says use Kestrel, which is the web server. We'll talk about that a bit more. It's got IIS integration for running under IIS, which we're not using right now. Then goes to the startup, which sets up some more stuff about our hosting environment. And then inside here, we've got a few basic, a controller, a few views, and a www root folder for all our static resources. Okay, so that's what we've got from the template. Let's try and run it. So the first thing to do is a .NET. Well, that downloads all our NuGet packages and installs them. So let's do that. And hopefully on a good enough internet for this to work. Should be, because it's our internet. That's finished. Now I can do .NET run. And that's it. It's built and it's running, and it's now listening on port 5000. So the big change here, and this is across all of the .NET, ASP.NET Core kind of system, there's no need for IIS. A lot of work has been going on the past 2 years to get rid of that system.web namespace that assumes that IIS is somewhere behind the scenes bootstrapping the whole thing. So now IIS is gone. It can run quite happily in its own self-contained server called Kestrel. There it is. It's booted up. It's listening. Let me take a look at port 5000. There it is. It's running on Linux. And so what's remarkable here is how unremarkable it is. You type a few commands, you hit run, it works, and there it is. It's running a website. Pretty easy to work with, pretty fast to work with, and yeah, the thing is, it just works. So now Control-C, I've shut down that website. Let's take another look. It's gone. Okay, so that's the first step. It can run from the code there, but if we take a look around, there's not much going on here. This is still my development environment. So this isn't really production ready, but what I can do to make it more production ready is I can publish it. So in order to run the publish and get the publishing to work, you need to install a few things. You need to have npm, bower, and gulp installed on your path. That's pretty basic, but once that's installed, if you can go .NET publish, give it an output folder, that looks right to me. That's now got to run a few things, and that's now published. Let's take a look at that. So take a look at that, and you can see there's far more DLL files. It's now, oh, I've lost it. There's far more DLL files in place now. It's now taken all the dependencies, all the framework stuff it needs, and wrapped it up and dropped it here. Now, by default, it wraps it up and builds a package that assumes that there's a .NET framework where it's going to run it. What you can also do is send some extra commands with publish and actually include the whole .NET framework with it as well. So you can actually ship that to a server that doesn't even have the .NET framework installed and have it still boot up. So if you've got issues where you want to have multiple versions of .NET framework, or if you're bundling for, say, a container that you don't assume .NET framework's there, you can actually push it to that container with the framework it needs. So you've got a lot of options there on how you publish. Now, when you want to run the app that's published, you still use a .NET command, but it's slightly different. You type .NET and the name of the entry point DLL, the name of the project you created. So that'll be MVC in our case, .dll. Again, if you've noticed that, the startup time now was a couple of seconds before. Now it's click, bang, it's up and running. So very, very fast. Having said that, there is a few seconds delay on the very first request.
And what's the reason for delay?
I guess it's the first request is starting up, yeah. I'm sure you could actually set up a first hit request or something to speed that up, but it's still it's still noticeably faster than using IIS ever was. So let's close that down. Let's kill that. Okay, so we've got an ASP.NET Core web application. It's built, it's running. Let's take a look a little bit more about the web server. So that works so quickly and works so well because of a built-in web server called Kestrel that's kind of built into the ASP.NET, and it's kind of running, it's a self-hosting web server. It's a small, fast web server in .NET Core, and there's been a lot of work on optimization, a lot of crazy stuff they're doing with not writing C# code in the normal way, and So say I'm got a web request coming in, and the code that reads the web request and says, is this a get, is this a post? What you'd normally do is write, okay, compare the string. Does it say get, does it say post? That's not what Kestrel does. It's got some crazy bit twiddling things in order to get tiny bits of performance tweaks out of it. So they've done some crazy things, and they're getting some really big performance optimizations out of that. So yeah, like I say, it benchmarks much faster than IIS. I'm not putting any particular numbers because any kind of test is fairly arbitrary, but the baseline is if your actual code itself takes this much time to run, it's always going to be that much time if you've written the code a certain way. But if your framework is like that versus that, you get that stuff for free. That speed up is for free because the framework's not taking up those resources. So it's fully cross-platform. It's the Kestrel for version 1 is based on something called libuv, which is a cross-platform library actually written for Node.js. So this is a case of Microsoft not reinventing the wheel. There was this great library out there for doing fast web servers. It was in use for Node.js. They took that on when building the web server for ASP.NET. There is one issue though. Current recommendation for this Kestrel server is don't expose it directly to the internet. So if you look at that and think, what does that mean? It's totally fine, and it's totally expected, and it's what everything else does. So if you look at a Ruby, if you look at Java, this is pretty much what they do. And there's a reason for that in the fact that modern web servers have to have a lot of hardening code in there to react to things like certain types of attacks that they've added over the years. So what program developers don't want to do, or language developers don't have to think of all that stuff. So what you do instead is you put a well-known hardened web server in between you and the internet, and then you use that as a reverse proxy server and forward those requests through to your application, which means you've got a really hard-tested, well-known program at the front, and you're free to kind of iterate a bit more with your actual system in the back end. And this is pretty much a standard way of doing things now. Like I said, Ruby does it, Java does it. The other thing this is good for is, for a long time, like way back in the day with PHP and today with ASP, what would happen with your web application code is it would run inside your web server, which meant you were tied to the resources of your web server in quite a big way. So when, say, PHP wants to integrate with Apache, they have this feature called they have this binary code called mod PHP that's there to, inside Apache, spool up PHP and process requests and send it back all within the context of Apache. Then to do it for Nginx, they have to write it again, a module for Nginx. If you have this proxy approach, you can decouple the logic of your language, PHP, Ruby, Perl, .NET, whatever it is, have it fully decoupled and put whatever web server you want in front of you. You don't have to then create custom modules for each of your web servers to run your different languages. So I think it's definitely the way things are going to go in the future, to have that decoupling between your edge-facing web and your actual performing web. So let's take a look at how we then set this up. How are we going to set up a reverse proxy to our ASP.core application? So how do you go about finding about this? Pretty much the same way as you go about finding about anything you want to do on the internet. Just because we've moved to Linux, nothing's changed. We copy and paste from Stack Overflow. We do a web search and we find what we're looking for. So let's take a look at that. So the first thing we need to do is install a web server. And it's that simple. You type sudo install nginx. I'm not going to hit go because I've done that already. So let's take a look at the configuration for nginx. And as you've seen before, if you've got any configuration files, they live in /etc/name of that program. So let's take a look there. There's a couple of important folders here. One's called sites available, one's called sites enabled. So sites available, it's really a folder to put all your kind of virtual hosts, your virtual name hosts. And sites enabled works by actually putting in, you could have more sites in there that are actually turned on. To turn one of those sites available files on, you put a symlink in sites enabled into that other thing. So if I take a look in sites enabled, just to give you an idea, and do ls-l. This folder doesn't contain files, it contains pointers to point to files in the other folder. So if I want to turn on another configuration file from that folder, I'd create a new symlink in this folder to point across. So let's take a look at that sites available. What have I got for default there? Okay, so right now what's there is the default configuration. So if I go sudo nginx start, no, sudo, sorry, systemctl. So what we're using here is a program called systemd that it all installs when you install nginx. So system control, name of the program, and start. It's pretty much your services to MSC equivalent of. If I do that, get it right, sudo system control start nginx. That's the right way around. Okay, with that in place, if I browse to localhost, okay, I've got a web server running on my box, and it is called nginx, and it's got the default hello world page on there. If I take a look at the configuration, I will see if I scroll down, it's listing on port 80. I don't have SSL configured, and my home folder is var www.html. Okay, well that's the default configuration. We don't want that default configuration. We want to do something else. So I'm going to stop nginx. Actually, I can leave it running because you can change the files behind while it's running. I'm going to copy a different configuration file into place. Don't forget the sudo. So if you are doing a lot of stuff that needs a root console or root privileges, there's one little trick you can do that you should never do, and that is sudo bash. And that gives you a complete shell where everything from that point on is then running as the super user. You probably shouldn't do it like I do all the time. So let's take a look at that now. If I cp my proxy configuration to overwrite that file, let's take a look at that file as well. So what we've done is replaced the entire configuration for the nginx server, and this entire block was literally cut and paste from Stack Overflow. We're listening on port 80. Everything that's underneath port 80, so everything under the / location, we're just going to proxy it through to port 5000. So let's take a look at that running. I just do systemctl n. Let's go reload nginx, because we don't need to restart it, just need to reload configurations, see if that works. Go to port localhost now, and I expect this to work because my website from port 5000 isn't running yet. So we've configured a gateway, a proxy, but we're not actually running the ASP.NET side of it yet. So let's go and start that up. code MVC underscore published. Then to run it, it's .NET mvc.dll. Okay, so now running our ASP.NET side, listening on port 80. We've also got our proxy running on, the MVC is running on port 5000. We've got the proxy running on port 80. We now hit go. And now website's up on port 80, so that's now ready to go out to the outside world. We'd obviously leave port 5000 behind the firewall and have port 80 open for general purpose traffic. So that's running as a proxy, but there's one more thing to look at. That's sitting there waiting for something to kill it. If I had to kill this terminal, if I was to hit Control-C, I've just killed it and it's now not running. So how do I set this ASP.NET side of it to run as a service? Well, to do that, we can use the program again called systemd. And once again, it's a piece of code we copy and paste from Stack Overflow. Hopefully by now, if there's one thing you've learned, it's where to find configuration files. And that's under etc. So the etc/systemd. Let's take a look at system. And I've got a configuration file I prepared earlier. Here's a configuration file for running this particular service as a service. A few interesting things. You give it a working directory, which is where that published folder is. You give it a command to start up. So there's a .NET command, and there's a DLL, exactly the same as how we run it by hand. Then we've got a couple of interesting things. One says restart always, and restart 10 seconds. If it detects that system has gone down, it will automatically restart it for you.
So if you change it to like 0, 0 or 1 second, so would it restart after that, or is it like a...
I think it's probably nicer to leave a few seconds for it to finish crashing before you start it up again. Okay. You could probably make it down to 1 second maybe, but I guess you're detecting it's crashed. But I think 10 seconds is enough to, in real terms, get it back up again, I think. If you're sort of worried about sub 10-second response time, you should probably have a farm of these things out anyway and have a load balancer. Okay, so that's a pretty simple configuration file. It fits on one screen. Most of it is where to run, what to run, and the fact that we want to restart it and give it some properties. Let's take a look at how we run that. So we do sudo systemctl enable and that file name web01.service. Okay, that's now enabled. What enabled means is next time this machine starts up, it's set up as a service, it'll get started up with the machine. I don't want to wait till I boot the system though, so let's actually take that and start it now. So that's system control start, web01.service. What did I get wrong there? Sudo system control start web01.service. Okay, that should have started. If I want to check to see that started, I can type status. Okay, that's looking green. And you can see in here it's got the text output we used to get when we're running it by hand. Okay, so let's take a look at the port 80 now. If I do a quick reload. Okay, that's now running, and it's running as a service.
And say if this is not accessed by anyone, right? So does it die automatically, or it just keeps on running?
As far it just keeps on running, and in fact, I'll show you the next bit. Not only does it keep on running, for because on IIS, if a site's not being hit, it gets taken off for some reason I've never understood. But yeah, I mean, IIS seems to be tuned for high workloads. If there's workload coming through, it'll keep it alive. But for some reason, it thinks no one's hit it. I'm going to shut it down and do everyone a favour. And the amount of trouble that causes me, no end. So this stays up. Not only does it stay up, let's be really nasty to it now. So we know it's running. Let's see if we can find that. Okay, we've found this .NET process. You see, whenever you search for something using grep in the PS, you'll also find the process that's actually running the grep as well. So that's the price. That is the process finding itself. And here is our actual process. There it is, userbin.net, and it's got a ID of 6507, and it's running as me, so I can just get up to it and kill it. So let's do that, and let's be really nasty. Kill -9 6507. So that's about as nasty as you can be. That will immediately terminate the program. Won't terminate nicely. It's going to kill it dead. 6507. Done. Let's take another look at that thing in a few seconds' time. Maybe there. What's this? Is a process running. It's called .NET, and it's been given a new process ID. So if I come to my website, you should see my website's still alive. So even though I killed the process completely, it's been immediately restarted by the systemd system. So there it is, alive and up, and it stays up, and it comes back up really quickly. One final thing I want to show you, and I'm going to spend too long on it, is you've got SQL Server running on Linux. And the way you install SQL Server on Linux, as you can probably guess, is you need to install a package source into apt, and then do apt get update, update install. So once you've learnt this thing once, you can use it for everything. That's the whole point, really. Yeah, I'm Googling it. And this should all look really quite familiar. So what you've got here is, as you've seen, some text to copy and paste into the terminal. It's slightly different text. They're using a different command called curl. So they're downloading something, and they're passing it through to apt, and they're doing add. But actually, you're doing exactly the same thing. You're taking this file, and you're adding it to the package sources. Then you register a key. Then it's apt-get update, apt-get install. And if I go to my package sources here, you can see I've got quite a few different package sources in there. I've got the .NET, Google Chrome. I've got a custom one for Google Chrome in there. And I've got MS SQL Server in there as well. So there it is, and that's how you install it. I've also installed something called SQL Server Tools, which means I can go to here. And I've got a couple of little text commands here. SQL command and BCP. So these are the really low-level command line ways of interacting with SQL Server. So I type /SQL command dash. I'll just type that to get the switches up. -s localhost and let's give it -u. I've actually installed a Northwind database here. Put a password if I use my Northwind database. Go. If I select star from contacts, I think it is. Oh, it should be go. Good questions. The question there is there a GUI for SQL Server on Linux? And I will come to that in a second. If I just run this, because yeah, this isn't a great experience, is it? There's plenty of other text-based, most Unix-based databases have a text-based option for interacting with a server. I think SQL command is the most basic one out there. It does work. It's probably good for invoking SQL as part of automated scripts, but it's not that fun to work with. See if I can get it to actually do something. Use Northwind. You've got to type capital Go in capitals for it to work. There we go. It does at least have some history there. Now if I go select star from, I think it's customers from memory. Most systems that would be enough, just put in the semicolon. I've got to type Go as well. And there we go, we've got a query running. So it's pretty basic, but there are some options for doing that from a GUI. So there's plenty of open source user interfaces for databases that work on pretty much any ODBC data source or any. There's a lot of Java ones, and they have this thing called JDBC, which is a Java wrapper between you and the database, and they will all work with MS SQL. Your other option is you can actually exit this, come straight in here, and if you set up the right path, you can just use you can connect from your Windows thing here through to MS SQL. So you can't really see this very well, but that's local hosts, and for some reason that I really don't understand, if you want to specify a port in an SQL string for Microsoft SQL Server, you put a comma and not a colon like everywhere else. Everywhere else in the world you put path colon port. In here it's a comma. So what I've done, this is running on VirtualBox, and it's running on VirtualBox with NAT style networking. So what I've done is in VirtualBox I've set up a port forward. So 1433 on the host system, 14333, an extra 3 on the end. I've set that up to forward through to 1433 on the Unix box. So that's now going to let me connect. So if I connect through, get my password right. Log in, there I am, and it looks just like a normal SQL database. Let's change someone's name or something. Let's do something to prove I've actually been here. Let's go to a customer. Let's edit the top 200 rows. Oh, it won't let me do that. Okay, it's not quite like any of the other one. If I right click and type select top 2,000 rows. Okay, let's just set someone's name. Update. Customers set customer ID equals Mickey Mouse. We'll call it M. Where customer ID equals 1. Let's see if that runs. Update customer set customer ID equals M mouse where customer ID equals 1. So that's this first guy here. Oh yeah, of course, yeah. Gotcha. ALFKI. ALFKI. Yeah, thanks for that. This is mob programming. String or binary data would be truncated. It must be. Let's make it mouse. That's obviously a ALFKI MOUSE. It's obviously got a fixed width. All right, there's IDs off that. Let's change something else. Set company name. Yeah, I can make that much bigger, couldn't I? Yeah, company. Let's have a look. Does this work? No, it doesn't. I'll have to view. There we go. That's more like it. And what was it? We're going to change company name. There it is. Company name equals master customer ID equals ALKFI. Okay, we've changed something from there. Let's prove that that is actually something we've done in here. Okay, set. No, use Northwind. Select star from customers where customer ID, and who can remember it's ALKFI. Sorry? ALFKI. Thank you very much. Go. Okay, so that really is SQL Server running on a Linux box. And yeah, as I've said before, just like on Windows, it is quite resource heavy. But it's there, it works, and I've not. There's a few teething problems.
Sorry, what version of SQL does it run? Is it like SQL Express or Enterprise? Or?
That's a good question. The question was, what version of SQL does it run? And I'm not entirely sure. Let's have a look at the. Now I know there's quite a few things that don't work. Like I know full text searching is installable, but a lot of the business intelligence tools aren't there yet. So it is the kind of base enterprise. Yeah, so when you're talking about say enterprise, it's got all these enterprise extra features, the features on top. A lot of that stuff, Swift, a lot of that stuff isn't in there. None of the business intelligence, reporting services, that kind of stuff isn't there. So it works as a core database. It's not got a lot of the features yet, but I guess that will change as and when demand. But you know, if you want those big corporate features, you'd probably would be wanting to run with the full stack anyway. This is more for people that are looking to. This gives you a kind of database that you're familiar with to run your web apps in a kind of familiar stack. They're looking to compete with, say, the LAMP stack, the Linux, Apache, MySQL, and PHP stack. This is now a place that fits into that slot. It's not a complete one of Microsoft SQL Server yet. And I'm pretty sure there'll be features that they're not planning to put across. But as a working database, it's there, it works. Not too many surprises.
Because like currently we use Postgres on Linux box, but if you can install SQL now, so it's
yeah. So previously, your best option was, well, you could always go for Oracle, but I find that introduces more problems than it solves. And one of them being you've got no money left. And so, a great option for running databases on an open source stack is Postgres. It's the thing I'd probably recommend first and foremost.
What's good about it, Brendan? Just everything?
Yes, everything about it. It's because obviously MySQL is the one that everyone talks about, but it just never liked it. Never seemed to have transactional support from the get-go. It was kind of bolted on later, and it always seemed to be a bit rough and ready. Like it was sometimes MySQL, sometimes very fast at reads and used a lot for web content management because you could get really fast reads out of it because it doesn't do proper transactions at the time. But Postgres has always been a very good, proper ACID compliant, really good, solid database. And I've actually been involved in taking a national franchise and moving them from Oracle to Postgres and being much happier. Because we could maintain it ourselves and not have to spend ongoing money to contractors just to come in once a month and make sure it was okay, keep it ticking over. Where Postgres, just you put it in, it worked, it did everything we asked it to do, and it wasn't too difficult to use. So I've got a lot of love for Postgres, so I'd recommend trying that out. And also, this is great too. SQL Server on Linux works. Give that a go.
I haven't used it, but I was reading the other day that they've replaced MySQL with MariaDB.
Yeah, that's right. There's all kinds of weird stuff around. Basically, the projects behind MySQL had a bit of a split, and they forked the code. One code went somewhere, and one code base went the other way. It's a bit like the split between LibreOffice and OpenOffice. Basically, the developers disagreed, so they went marching off. Both took a copy of the code and went marching off in different directions. And it's never a sign of health when that happens. But I've always found the Postgres community to be really supportive. Like you're reading mailing lists and you're talking to the developer of Postgres and some, really helpful people. And I've always found it to be, better supported than support that I'm paying for. But that's my experience. Your mileage might vary, but I've recommended it as something to try. It's got a learning curve, Postgres, but it's like a learning curve with Linux. Once you learn it, it makes coherent sense and things slot together, and it's a well architected solution. You stand back and think, I can see what they've done. I can see how it fits together, and it's nice and clean and simple. Let's get back to the slides. Okay, so what did we talk about? We talked about may you live in interesting times, a little bit of history. We talked about package managers, and if there's one thing you take away, there's two big things. etc is where configuration files are, and packages is how you get system installed on your Linux box. If those are the only two things you come away with, then you're going to have a much easier time next time you sit in front of a Linux box. We talked about the command line. We installed .NET and saw just how a few commands get you from nothing to it's running a website. And we then went on to do a full ASP.NET web application behind a proxy server, everything ready for production. And then finally a little bit of time left over, so we also looked at SQL Server to complete that stack. Please, 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 on your way out, complete an evaluation form. It's really helpful for us. It helps us know what you liked, what you didn't like, how we can improve. And for me personally, it's going to be great feedback because I'm looking to take this same talk more places. I think I need to shrink it down some more, but it is really, really helpful for us to complete an evaluation form. Moving forward, I really, really hope that some of you give .NET on Linux a try. And please get in contact with me, find me on Twitter, and take one of my business cards, and get in touch and keep an eye out for my blog. Thank you for your time.